So welcome to another episode for another webinar for Bytes and Insights. This is a virtual series that we've been running for the last 6 weeks. We've been doing, actually the last 3 months, we've been doing every other week a webinar at noon on Wednesdays Eastern Time in the US. This week we are being joined by Dr. Katie Schafer, who's going to be talking about basically the next steps after you build your R model. So this will be a technical webinar. Just a quick overview on the agenda. So we'll just do some quick introductions in the beginning here. Then Katie will have the floor for about 50 minutes. Feel free to throw in your questions into the Q&A portion of Zoom. So if you look, there should be a chat and a Q&A. Q&A is where you can ask your questions, and Katie and I will be monitoring those throughout the session. And then finally, we'll close out with some remarks and give you information on how to access the webinar. So just a quick overview of Bytes and Insights. Like I mentioned, this is a free virtual series that we've been hosting for the last 3 months. It consisted of panel discussions, fireside chats, technical webinars, and book chats. These events are all free and they're accessible online. If you missed out on some of the previous sessions that we did, we record all of these sessions and you can find them on our website. If you go to our website under Get Involved, you'll see the link, and then there's all the recordings there, or you can go to our YouTube channel. A little bit about Women in Analytics if you're new to this organization. So our organization basically exists to increase visibility of women that are making a significant impact in the analytics space and provide a platform for them to lead conversations around advancements of analytical research, development, and applications. Our new membership platform is live. We launched that back in May. So if you're interested right now, you can go and check out our job board and our upcoming events, as well as just general analytic events that are being hosted in the community that we've curated for you. And we have a lot more coming, like a resource center, online learning groups, things like that. So sign up as a member. It's free right now, and you'll get updates on those benefits that we're going to be bringing to our community over the next couple of months. And then also just a quick note, we launched our merchandise recently. I'm currently wearing one of our new hoodies, which is like super comfortable. So if you go to womeninanalytics.com/shop, you can find all of the merchandise there as well. And Our Ladies, so that is an organization that is a worldwide organization. Katie runs the Our Ladies Columbus chapter, and we are partnering with them on this event. Their mission is to promote gender diversity in the art community, and you can follow them on Twitter and then also on their website. Just a couple of webinar tips. So if you're having any audio issues, you're welcome to send us a chat or email us at info@womeninanalytics.com. If you have a question, as I mentioned, feel free to post it in the Q&A. And then we can get to that either throughout the session or at the end. And we're actually going to kick today off with a poll. But first, before we do that, I'm going to do a quick introduction of our speaker, Katie. So Dr. Katie Schafer, she is currently the Director of AI and Automation at Covail, which is in Columbus. She is a co-organizer for Our Ladies Columbus and also a Tidyverse instructor for so she's RStudio certified. She has received her PhD from The Ohio State University with a focus on experimental and quantitative psychology. During her PhD program, she worked as a graduate research associate at Nationwide Insurance Center for Advanced Customer Insights, using experimental methods and statistical analyses to optimize customer outreach and risk assessment. At Covail, Katie has worked on a variety of AI projects across several industries as both developer and project lead. Outside of work, Katie is an avid R user, RStudio certified trainer, and proud co-organizer of Our Ladies Columbus Meetup. In 2019, she was named a top 30 under 30 in the Columbus technology scene at the Tech Power Players Summit. She also serves on advisory boards for Franklin University and the Eridos Institute. She has been a member of WIA since 2017 and focuses on content curation and speakers for WIA for our conference. All right, so welcome, Katie. Thanks for being here. Before we jump into it, I'm going to launch our poll. So if everybody could take just a few seconds to, I'm going to allow panelists to vote as well, so you and I can do it. So there's a couple of questions on here. The first is, when it comes to statistical programming, I use, and you'll want to check all that apply. The second question is, in either R or Python, I regularly do the following. And again, this is a multiple choice, and so you can check all that apply there as well. And we'll just give everyone a few seconds to fill that out. All right, any last minute people filling out the poll? Throw your answers in now. We're going to end the polls shortly. All right, thank you. So I'm going to share the results with everyone. We have 77% of folks on the call today are using R. Others are using Python, Excel, and Tableau. And most people create a predictive model. Some are writing repeatable functions, and then also saving the trained model as an object for later use. Awesome. Thank you, everyone, for sharing that with us. And with that, Katie, I'm going to go ahead and stop sharing and let you take over.
All right. Just get my content up here. Okay, let me know if you can see that first slide, okay?
Yep.
Awesome. Well, thanks for having me today, guys. Hopefully you'll learn kind of a little bit end-to-end on what to do once you've built a predictive model. The end goal we're working towards is deploying a model, but there's a lot of steps to get there. So I'm going to try to provide kind of a brief overview of each. Hopefully it'll give you a sense of where your gaps are in understanding and where you can dive in a little bit deeper. And feel free to ask questions throughout. I will probably get to most of them kind of throughout, but we'll also save time at the end too. So before we jump in, just kind of a shameless plug. So myself and my co-organizer of Our Ladies Columbus, Esby Kreisman, are actually putting on an intro to our workshop August 10th and August 11th in partnership with Women in Analytics. So you can register for this workshop on womeninalytics.com. It's going to be 2 4-hour sessions. So both of those mornings, I believe it's from 8 to 10 a.m. And so if you are kind of newer to R, maybe even consider yourself intermediate, I think this would be a great workshop for you. So we're going to cover kind of all the fundamentals of data cleaning, munging. We might get into kind of a little glimpse of some tidy model stuff. So Esgy's actually interning in our studio right now, which is super cool. So she's kind of an expert on that. And we'll hopefully kind of leave you walking away just, knowing a lot more about R and being more proficient in it than when you started. So that's the goal. If you're somebody tinkering in Excel a lot and you're really trying to get to the next level, maybe you started R, but don't really have a solid foundation just yet, I think this could be helpful for you. All right. So it seems like most people on the webinar have built a model in R, which is great. And once you build that model in R, it's kind of like, well, what's the next step? So whether you're delivering that internally or externally to a client, typically the model goes somewhere after that, or the hope is that it does, right? So you want users to be able to use your model, consume the results. And we'll see that we'll learn about something called Plumber and then packaging of our functions and models in R. And these are great tools to allow you to kind of communicate with the next realm of individuals, because not everybody understands R. R is a little idiosyncratic. So tools like Plumber allow us to deploy our model as a web service or an API and give kind of an interface to it that is more of a universal language of the internet, right? There's a few things we need to do before we get to that step to really kind of set us up for success here. So I like to refer to these, along with my coworkers at Covail, as the train, predict, and package steps of modeling. So you have already trained your model at this stage. We'll talk about the predict function and how that works, but you've already made predictions. Now we kind of need to just package that up, get that into an R package, which we'll see is made up of a series of functions, which is kind of our code being contained in kind of self-sufficient functions. We'll save out that trained model object as a predict function. We'll package that into a reproducible R package, and then we'll go over briefly what deploying this as a web service using Plumber looks like. And there's just some code on the right of where you might be at this step. So if you've already trained your model object, maybe you've got an XGBoost model, this could be what the code looks like. Hey, I've made some predictions, my model looks good, but what do I do from here? So why is all this important? Because you'll see we'll go over a lot beyond just deploying the model itself, because there's a lot of steps you need to do to even make that step successful. So it's important because good code is kind of our foundation. So it's like the foundation of a house. If the code is crap, then the foundation is going to crumble and the house is going to kind of fall in. So good code needs to be reliable, needs to be reproducible, flexible, scalable, and long lasting. So how do you ensure good code? So I think, some main stuff that we'll cover today can set you up really nicely. And then you also want to get user feedback and do some testing and go through the steps of packaging and integrating that code, because that will really kind of reveal your weaknesses in that code as you go along. All right, so kind of getting into more of the specifics here. So I talked about functions. So let's say you've written your model. So I've got the kind of XGBoost model I wrote. And now an important step is to make sure that all of your necessary code for calling that predict function or that model you've made is tightly and kind of neatly compiled into a series of functions. And these functions, typically what you want them to do is follow kind of logical steps in your workflow. So in almost every single modeling scenario I've encountered, your data, your input data, is typically never just ready to go off the bat. Usually there's some cleaning you do to that input data, or what we call feature engineering, so building the predictors that actually get used in your model. So that's the perfect example of kind of the lines of code that you might want to bundle into what we call a function. So kind of what is a function? A function basically just allows you to automate kind of common tasks in a kind of more powerful and repeatable way than copy and pasting. So a typical practice in when you might need a function is the do not repeat yourself rule. So if you find yourself doing the same operation over and over, you don't want to repeat yourself. It might be time to write a function for that. And the thing about functions in R or Python is you use them all of the time. So if you load a library or a package, which is kind of a set of functions we'll learn in R or Python, you are calling functions that somebody has written for you. So for example, on the right here, I have an example of a really basic function I wrote just to compute the mean of two numbers. We'll see this function has a few weaknesses, but it gets the job done. So it performs just the mean of these two functions, and it has arguments or inputs to it. It's got the body of the function, and then it returns some value. So when it comes to packaging a model that you built, we'll see that it's important to package up all of your cleaning code and your predict function into a series of functions that can then become available later to what's called a kind of our Plumber workflow, which will deploy those functions out as an API or as a web service. And so this function building is really essential for deployment because it's going to make our code easier to understand, packaged all in one place, which we'll see is essential. It's also going to be much easier to deliver updates. So once your model's deployed, it's likely that there's going to be several changes needed. And that is much harder to do if you don't have your code written in a series of functions, because we'll see that changes in one function kind of get deployed throughout the entire workflow when we have a package that's been created that compiles all those functions. So you only need to kind of update code in one space or one spot. It helps you avoid making mistakes, because we're not copy and pasting and having silly errors. And we'll see that when we go to build the package, we'll want a function for each kind of step in the workflow. So that's a little bit about functions. I would guess that probably a lot of you on this call have written a function before. And to learn more, though, you might want to check out some of these books. So there's Advanced R by Hadley Wickham. So this is really a great resource. So I have it pulled up here. So this is a book. It's available online. You can also purchase it. And this is really the foundations of R. Same with R for data science. There's a whole package on functions in here, really foundational. You can find the exercises online. And writing a good function really just takes practice. So you'll see there's kind of few things you want to kind of always keep in mind in terms of naming it, having warning messages in it. So you'll see here on the right, this is actually, us debugging the mean function that's built into R. So it's much more complicated than my simple function was. But that's because it's designed to take a variety of different inputs and deal with kind of various errors that a user could trigger by their inputs. Okay, so we've got kind of our functions, and I mentioned that we're going to want a function for basically every essential step that we need to perform in order to call our model. So cleaning the code, for example, feature engineering, prepping, and then we'll also need what's called the predict function for actually calling our trained model object. So that's kind of the next step. So we'll see here on the bottom, I have a sample of code for what this could look like. So let's say I've got my kind of silly little model. I've trained it up using XGBoost, and I've saved it as a model object, my model. And then what I need to do, though, is I need to actually save this trained model object. And I can do that in R using what's called kind of the save RDS function. So hold on just a second. So if you see my code at the bottom, I've got the save RDS function, I've got my model, and then I'm going to save it in a specific location within my package so that I can reference it later in what's called my Plumber workflow. And remember, Plumber is the tool we'll use to deploy the model as a web service. So we need to save our trained model object so that can be called on later, like I mentioned. And once we create our package, we'll want to put it in a specific place. So a common place to put it is what's called the xdata kind of file, or it can be, you'll see that there's a file that's specific for where we put kind of saved objects in our package. And I'll go over that in a little bit. So the reason we want to do this is because typically, and this is not always the case, when we deploy our model, typically we don't want it to retrain every time. Sometimes we might. But typically retraining or training the model takes a while. It's pretty computationally intensive. So if you have a scenario that's not changing all the time in terms of kind of meaningful inputs, you typically want to save your trained model object and then call on that once your model is deployed. And you'll see that a lot of the workflows you can look up on deploying your model follow that framework. Now note, it's important to be kind of an informed consumer here. So I know kind of a common concept in machine learning is that models are continually learning, relearning, getting smarter over time. And so you will often hear people talk about models in this way. But it's important to understand that this does not just happen magically, this kind of retraining or relearning function. In order for us to do that, we would actually need to set up and deploy our model in that way. So we would actually need to set up a framework where this training step here in my code is happening continually over time. And we'd need to do that in kind of a conservative way to kind of reserve computational resources. So we would have to make decisions like, how do new observations get appended to the training data set? How is the training data set? What does that look like over time? And then we'd probably need to deploy as a web service a second function for retraining that model. So we're not going to get too into that specifically. I'm happy to take some questions on it. But I think this is just a common misunderstanding I see in the field, is that models are continually learning or training over time. And they can absolutely be set up that way. But out of the box, when someone typically builds a model, typically they go through kind of the training steps and then they save that trained model object. And then that trained model object gets called on a new set of data to make results. So if we want that model to be continually retrained, we have to strategically build that into our workflow and create that retraining function. Okay, so now we're into what I call the packaging step. So once we've got our series of functions for kind of cleaning, prepping the data, we've got our predict function, and we've saved that trained model object somewhere, and we'll use that later in our package. Now we're getting to the point where we want to package those cleaning code and the associated functions into what's called a reproducible R package. So again, you use packages all the time if you're using R or Python. And packages are kind of just a collection of functions that have been curated for you and allow you to kind of easily access tasks and have documentation associated with it typically. So I'll briefly go over how to actually make a package given your cleaning code functions, your prep or feature engineering functions, and then also that saved trained model object. So creating a package in R is actually fairly straightforward. It seems like a really daunting task, but it's relatively straightforward to do. So we can actually use the RStudio GUI to create the package and kind of all of the essential files that we need by just using kind of some of this point and click interface here. Or you could do it in the kind of terminal command line, or you could do it in RStudio itself. Lots of different ways to do it, but there is kind of a nice, easy user interface for doing so if you prefer that. Okay, so we're going to go kind of quickly over some key components of a package in R, kind of how to make it. And ironically, there are some packages that help you make a package in R. So we'll go over those. And hopefully this will give you a sense of what you do with your functions and then that saved predict function that we talked about, that saved trained model object. So a library, this is typically what you use to load a package in R. This is simply a directory containing installed packages. And we'll see that there's various package components that you want to be mindful of. So the main chunk of components of what you'd think of is your actual code. So this is typically in R, in an R package in a directory called R. And this contains our scripts. And our scripts are typically in a package framework. We want these to be a series of functions, because we'll reference those functions in other portions of the script. So we might have a script or function for cleaning the data. We might have a script or function for getting the predictions from the trained model object. And so we want to kind of organize our scripts in reference to tasks that we'll be performing. Kind of the next component of a package is going to be some of the package metadata. And we'll see that this falls into something called a description file. So if you actually go to GitHub and look at a package, you will see these various components. So if I actually go to GitHub deploy-r, for example, this is a really common package. So this is something you use all the time in R. But I'll actually see these components. So I can see my description file here. I can see my licensing file. I can see my R file. And this is going to be crazy for something like deploy-r. But here are kind of the series of functions that deploy-r uses. And some of these might look familiar. So you might look at something like mutate, right? So this is a key function we probably use all the time. And we don't even think about everything going on under the hood, which is actually within this code here. So this hopefully gives you a sense kind of what the package looks like. So again, we've got our GitHub. We've got all the different components, which I'm reviewing right now. Right now I'm on the description file, and we'll go over what that is. But we just went over kind of the R directory within the package. And again, the R directory contains a series of scripts, which are kind of in reference to functions that will be used or available within the package. All right, so getting back to the description file and what this includes. So this is kind of the package metadata. And basically what this is it records what packages are needed to run your package, who can use your package, the licensing information, whom to contact if there's a problem, so actually your contact info. And then we'll see that typically it has kind of an import section with the packages that your package relies on. So for example, you might use a package like XGBoost in your package to kind of either train your model or call that predict function. And you would want that kind of listed out in your metadata file. And we'll see that there's a package that kind of handles this for you. But here's kind of a really basic one. So my package, description of what it does, authors, some dependencies, and then some licensing. So we'll see there's even a package that will put something like, the open source licensing language or MIT licensing in here for you. But if you're working at a company, you might have a proprietary licensing file that you want to incorporate. If we go back to dplyr, we can see that if we go to their directory, they actually have, their licensing file right here. So, and we can see that this is updated a few different places, but RStudio is the license holder there. Okay. So getting back into other components, again, I won't do deep justice to any one of these, but hopefully it gives you a sense of what these are. So we'll see that we've got a man directory, and this is kind of the object documentation, so kind of our manuscripts here. We can use a package called Roxygen2 to create this for us. So if we run the DevTools document command, this converts Roxygen comments, which is just kind of the name of the package, into .rd files, so files that can be used to actually create that documentation. And so what is the documentation? So basically, if you're in an R package and you type $mean or $GLM, that documentation that comes up for you in a viewer, this is how that is created. So this is where that happens for us. And again, Roxygen is just a package that makes creating this easier. So once we're in our script files in that R directory and we write out our functions, if we format the headers with some documentation in a specific way, then once we run this DevTools : document function, it will actually take everything within each of our R scripts and it will create the documentation for you. We don't have to mess with it. So it generates the documentation associated with each script within our R directory. We can also create what's called vignettes. So in R, if you've used a vignette before, it's basically a really awesome tutorial that a lot of functions or packages have. And you can create vignettes similarly using a DevTools function called useVignette. And again, what we do is this creates a vignette directory for us. It adds kind of the necessary dependencies to our description file. And we'll see that we can draft a vignette using something called R Markdown to create a .rmd file. So vignettes, again, we can do in this manner. This DevTools useVignette function can help us out. We won't get too much into this, but tests. So tests are another thing you can incorporate in your package. So this is really useful if you want to, kind of see how your package is going to perform with different user input. So you might want to build tests to see, hey, what happens if my function is expecting, a series of character strings, and instead somebody submits something that's an integer, right? Like, what happens? Does it break? How can I handle that exceptions? And that's what the test package does. And so you can build in those tests to make sure everything's running well and see how things respond to various input. We've also got a namespace file that's in packages. This is really vital for CRAN submission. We're not going to get into that in terms of how to submit packages on CRAN, but in terms of deploying your model, kind of what you need to know is namespaces is really kind of an essential file that specifies your exports. So the functions within your package that you want others to be able to use, and your imports. And these are other packages to be used by your package. And if we use Roxygen and we kind of do our documentation properly at the top of each of our R scripts, this namespace file is going to get created for us. And so Roxygen2 kind of handles that for us, and we don't really want to touch this file. We just want to let it get created for most scenarios. Then we've got a data directory, and this may be any sample data set that you want to include in your package. So if you're familiar with the mtcars data set, if we go into kind of the structure of the package, we'll see this is where data like that is included. So if we're within dplyr, right, and we go to their data directory, we can see some data sets that we've probably seen before in R. So Star Wars data set, storms, and these are data sets that once you load this package, these data sets will also be available to you. All right, and then, sorry, getting a little ahead of myself here. Last but not least, we also have kind of a file for installed, an installed directory for files that we want to kind of come with the package. So this is where you can actually save your model object and then reference it later in our Plumber pipeline. And this is where you might also want to save other data sources that you need to reference or saved our model objects. So it's different than kind of the sample data we might want to offer as part of our package. And this is kind of more pertinent to deploying a model. So typically when you want to deploy a model and you have an R package to contain the model and all the functions needed to call that predict function, you probably want to put that saved model object that we created in the last step out in this inst directory. Okay, so if you're new to creating packages, I would highly recommend this book by Hadley Wickham, R Packages. This really goes over every single thing I talked about in serious detail. So this is kind of the way to go. It's very easy to read as you're kind of creating the package, and it's really kind of a go-to guide for creating packages. There's also some packages I didn't discuss that make creating a package easier. So test that's used for some of the testing that I referenced. Here package kind of helps you place things in the right directories within your package. Use this is kind of a workflow package, so it automates some repetitive tasks that might arise during project or package setup. So it allows you to specify things like, hey, I want to use the MIT license. And it just places that license in the right spot for you. And then knitr, this is a way to kind of make some of that documentation, like the vignettes, look really nice. All right, so now we're kind of getting more into the deployment content. So we're going to talk about how to deploy your model into a web service API using Plumber, the Plumber package in R. So if we are at this point, we have ideally trained a model. We have then saved that model as a saved model object or trained model object. We've also taken all of our necessary code to call that model. So all of our cleaning code, our feature engineering, we've turned those into repeatable functions. And then we've created an R package that contains all of that. So our R package at this point should contain all of the prep code you need to call the model on a new set of data. It should contain the trained model object itself. And then potentially, if you want to incorporate some retraining functionality, it would contain that then as a different function. So now that we've got this R package containing all of this good stuff, this is when it's time to deploy it as a web service using Plumber. So this is something that I think was less native to me as more of an R user and somebody who came from academia and just somebody who's more into statistics. These kind of computer science concepts, I think, are important to understand. So we'll go over them just briefly in terms of what even is a web server or web service API. What is this? So an API just stands for Application Programming Interface. And it's basically a set of guidelines for dealing with the program over an interface. So HTTP, this is kind of the guidelines on the internet or the World Wide Web. So it's a specially formatted data structure that's being sent back and forth from a client to a server. So kind of what is a client? What is a server? Kind of think of it as like a phone call. So I've got somebody on the other end who's making a call to me, and there's a set ways that calls come in, whether it have Verizon or Sprint, right? And I've got the request and some info about it typically. So on a cell phone these days, I've got the caller number or maybe even the caller name. I answer the call, we communicate, and then the request is kind of closed out. So HTTP, this protocol allows us to communicate consistently across different servers. And so what is a server? A server is basically kind of our program, like a web server. And it typically runs, kind of somewhere else that I can reach from my local computer. So every time we go to a website, we are making an HTTP request. So I can reach a server elsewhere running this website from my local computer or workstation. And then I make my request, and what I get back are the results, typically the website, rendering in my web browser. So to kind of go over this a little bit more, if you kind of look at a typical website, we can see that we've got our host in there. We've got the address of the server typically, and we can kind of look at this in the command line if we do something called, kind of run a verbose statement to see what is contained in an HTTP request. So we've got other information like what the request is, and then we've got something called the endpoint. So, you know, kind of what is the object we're requesting? What kind of requester type is it? And we'll see that later on, when we get to deploying our model, the kind of data language of the internet is JSON, so JavaScript object notation. So instead of sending data frames in R across the internet, we're going to have to move over to JSON arrays, because that's how the internet communicates, basically. So an example of a type of request would be a GET request, where we get something from a server. And we'll see that we'll translate this later with things like post requests, where instead of just simply getting results back, we are sending something up, they're getting manipulated in some way, and then they're returning to us. So that's how we'll kind of deploy this model as a post request. So let's see here. So JSON arrays, I've already discussed those. Those are kind of the data frames of the internet. And this kind of client server architecture is kind of the key to keep in mind. I think we've reviewed that enough. And we'll see how this kind of works in practice in Plumber. So Plumber kind of makes using all of this infrastructure easy for us and easy to do in R. So this is a really basic version of using Plumber. But we can see here that we've got the Plumber package that we've loaded into R. We've got the input, and we've got something called curl here. So curl is kind of our requester type. And we're making a request to the server. So we've got the server number here and the host that's being run on. And then we've got our kind of requester endpoint here, which is the predict endpoint. And then we'll see we've got our output. So these are the actual results of this server request. So what does this actually look like in our package model deployment framework? So if we're getting back into our land now, to take advantage of all this, we can use something called Plumber. So Plumber is an R package that converts your existing R code to a web API endpoint using kind of a handful of special one-line comments and functions. So once we have used Plumber, we'll see that our model is no longer limited to R. This opens us up to the internet, and to allow us to work much more easily with people who don't work in R. So an R data frame is not going to be useful to them, and neither is our R code. So it takes the results of our model, packages them up, and makes them available to anyone kind of elsewhere. So we'll see this is kind of a basic workflow for how you might use Plumber in practice. So I've got my model, and we've already packaged it up into an R package. So here I'm going to actually load that saved model object that I saved out into my directory. And I'm going to reference that directory here, and I'm going to load my saved model object. And then this is kind of where the Plumber stuff happens. So right now I am basically importing a package called JSON Lite. We'll see that the # and the asterisk is how I make Plumber comments. @ specifies the endpoint or the attribute details. So we can see I'm making a post request to the predict endpoint here. And this is what it looks like basically. So I make this request. So I have this function where the input is kind of the data, the input data that I have, the request that has the JSON data that has been sent up from the person calling this web service. I use a package called JSON Lite, so that I can take this JSON array of input data. So these are the new observations I want to make a prediction for. I can take that array of JSON input data and I can convert it to a data frame so R can actually use it. Then I'm going to call my clean data function, which is contained within my package I wrote. Then I'll call my predict function. So this is kind of my custom predict function that I have in my package. And we'll see that I call this kind of saved model object that I loaded up here. And then I'm going to return these results. Kind of one step missing is I'm going to change these back to JSON array so that they can be sent back over the internet, back to the person who requested it. Okay. So that is basically it in terms of how to deploy your model as a web service. So I've got the steps kind of in review. I've got building my model in the first place, taking everything required to call that model, cleaning, feature engineering, and writing those up into reusable functions, taking those functions and creating an R package. And then taking that R package and building a Plumber workflow where I actually deploy the model within that R package as a web service. So this is where I think things kind of fall back into what you call like MLOps or a DevOps land. But basically you need to deploy this model somewhere. So kind of the question is deploy to where? So we need to deploy this model to a server somewhere. There's lots of different options for those, which you might have heard of. We're not going to get too into any one of these. But basically you could use something like a virtual server. So you could use something like an AWS EC2 instance. And this allows you to kind of run your application or your model and in a scalable fashion. There's other options here from Google Cloud, I should say AWS SageMaker, not AES SageMaker. And then we'll see that some people choose to use Docker in conjunction with their server. So Docker basically takes an application and all of its dependencies and encapsulates that everything into an application you need to kind of run and use that application. So it what's called can kind of containerize or self-contains everything on our application such that we can then run it on any Linux machine and kind of port it over easier. So, but you do need kind of that server infrastructure to run a Docker container, but it's a way for kind of tightly containing everything. Our Studio Connect could be another option for deployment. So you do need to kind of supply the server for our Studio Connect, but then after that, it's a really kind of easy to use publishing platform that makes getting your model out to your team or others within your organization very easy. And there's some considerations you might want to take into account in terms of how to deploy your model, some security considerations, kind of who you want to be able to access it and what that looks like. But these are kind of just some basic next steps after here and where you might want some assistance from somebody with some skills in these areas. But there's plenty of resources out there if you want to try to learn it on your own. So that is basically what I have today. So if you want to get a hold of me, here's my email, katiesasso@gmail.com. I've also got my GitHub account. Mostly this has a lot of talks from Our Ladies, but there's a few projects on there. Ourladies.com. So I know Reagan's shared a little bit of that in the beginning, but we are a free meetup. All of our meetups have been virtual lately. We try to meet monthly. So this most recent month, we had a presentation, which I did, but I'm kind of blanking on now in terms of what it entailed. But we had a joint meetup with Web Analytics Wednesdays where we talked about some digital analytics work. But these are all the topics we've done in the past, so lots of cool stuff. We meet monthly, like I said. We encourage men and women to attend. We do reserve the speaker spots for women and non-binary individuals, but we really would love to see you there. It's free, good place to learn R. And then kind of lastly but not least, Covail, the company I work for. This is kind of our bread and butter in terms of what we do. So we do a lot of automation work, deploying custom machine learning models, and then helping out with that kind of hosting and also building those models. So get in touch with me if that seems like something that could help you or your organization. And then lastly, info at our courses. So there's some really good local R studio certified instructors here in town, and they'd be happy to help you learn R a little bit more and kind of customize a course to your needs. All right, so that's kind of all I have. I would welcome any questions. Reagan, I'm not sure if you're seeing any on your end.
I actually have a couple of questions myself. So one question, and this is kind of more of a process related question. So based off of your experience building and deploying our models, are there typical, especially because you have an extensive background across different industries, and so I assume you're probably seeing a lot of different technical stacks. Are there typically like a set list of roles and responsibilities between the data scientist and other individuals to actually get the model deployed? Is it on the onus of the data scientist to do all of that work, or like how do you usually see interactivity of data scientists and other roles?
Yeah, it's a good question. So I'd say, in the consulting world, it kind of depends on the client's needs. So For example, we've worked with clients who use Google Cloud and they want the model deployed using that infrastructure. We've worked with clients who don't want to deal with the deployment, so we host the model for them. We've also worked with clients where, hey, we really want this as a Docker container and we want to work on deploying it. So we have some, I think, more flexibility there than most. But I'd say in any scenario, whether you're in consulting or whether you're in your own internal organization, really kind of one thing that whoever you're working with or building the model for needs to be responsible for is making sure that input data is available to you, and working to make sure that everything required for the model is always being sent up and kind of included in that request for the API. So that would be one element. I'd say mostly within organizations, when there's kind of a good machine humming, it does seem like there's kind of more of a breakdown between, where their work ends as data scientist and where the work starts for kind of what you call the data architect or data engineer or ML ops team. So ideally as a data scientist, I personally think it's great to have this exposure, but it is kind of hard to wear both hats. So it's really hard to know how to set up Docker infrastructure and deploy your model as a web service, and to also be really good at the modeling components. I do think it's really important you have some understanding of it, but ideally there's somebody within your organization or externally who can help you with it, because we really brush the surface of these topics, but these are really deep topics and there's a lot to consider here. If you go through like a Docker tutorial, it might seem really easy, but there's a lot of snags to hit when it gets to actually getting this stuff up and running and deploying it somewhere.
Yeah, I would say probably, especially if you're in a large enterprise organization,
Right.
where they've got a lot of security regulations and guidelines about deploying the R language in general, and just making sure that the underlying environment or infrastructure can support actually deploying an R model.
Yeah.
I mean, I have another question for you about like designing catching errors within your code. At least in my experience working with data scientists, they're typically like statisticians or mathematicians first and then kind of programmers second. And so there's this concept that you covered in the beginning about designing your code to be able to catch errors. And especially if you're going to deploy it into a production system, that's even more important. So from your experience, are there any resources you've used to help you kind of design that error catching component of the model?
Yeah, I'd say this is kind of a skill that you really need to build up over time. So I think it's something I've done less formally in the past, that usually I just catch the errors when I go to do something like package the model or deploy it, and then it doesn't work for some reason. So if anybody's in, for example, like sales forecasting, oftentimes fiscal calendars, when there's a leap year, cause you like all sorts of nightmares. So like that's a great example where I just didn't even think of the ways my code could break when a leap year would be kind of keyed in differently. All the little lines in your code that rely on different kind of components of the fiscal year. So I think over time you start to learn, the pieces of your code that are more prone to break, and you start to generalize things a bit more. But in general, I think that's where having some appreciation for something like typical software engineering practices can really help. Because I think as data scientists, sometimes we aren't so mindful of those like best practices in software engineering that are really, kind of built to do things in a way that requires kind of continual testing or something like paired coding, right? Like it's just typically not how we work. So there's some great resources by somebody named Amanda Gadrow at our studio that talk about how to build really good tests. She's given a few talks on it. So I would suggest kind of going out there and checking those out, because I think there's some things that might be kind of non-intuitive for somebody who's more in the data science or statistics realm.
Yeah, absolutely. I know I learned those concepts specifically from a software development perspective, but definitely not in any of the data science or analytics classes that I took.
That's right, yeah.
So we have a question from an audience member. Mary asked, is Plumber specific to deploying models, or is there a use case for deploying a web interface for other packaged R scripts? Is it a good way to present other types of analytics calculations in R to a non-R user?
So it kind of depends on your use case. So yeah, you can definitely use Plumber for basically deploying any, kind of web service or our, collection of R functions or an R package as an API. The one thing to think about with this framework is, typically your input and output is going to be JSON, a JSON array. So that might not be super intuitive for your end user. Your end user might instead want to like submit a CSV to you. So you could, for example, like deploy a web service that I guess, posts like a histogram or something. But a better thing for that might be something like a Shiny app. So you might want to use that instead if you're not deploying a model. And I'd say that's typically how I see things go. So if instead you really like what you're trying to display is more user interface focused, you'd probably want to deploy a Shiny app, and there's a few options for that versus use Plumber to deploy it as a web service.
Yeah, we got a note from a audience member, Ola, who asked what's a good package for simple visualizations deployment to a web page. So it sounds like our Shiny is probably the way to go.
Yeah, Shiny is definitely the way to go in terms of creating kind of interactive UIs, kind of like a Tableau, but I think it's way more powerful because you can have underneath the hood kind of more natively our models embedded in there, lots of computationally more heavy kind of manipulations. So Shiny is the way to go. You can deploy Shiny apps for free on shinyapps.io, or you can definitely deploy it in-house, also for free actually. But then there's also kind of paid services as well. But I would recommend checking out Shiny, the Shiny package.
So it sounds like this deployment capability that you reviewed today is really about this kind of automated process of running a model and retraining a model and letting a downstream system consume that data, right? As opposed to a person.
Yeah, so it could be a person, but yeah, typically it's some system that it's feeding into. It could definitely be a person. But the thing about, the predict function, it's kind of funny in a way. You have all this work that goes into it. And when you deploy your model, I mean, really what you're interested in most of the time is just those predictions. So just kind of a collection, kind of what you think of as like a column of numbers. So yeah, so I'd say that, that's kind of what it's all about, is just deploying the results that will hopefully then be fed into some system or some end user somewhere.
Do you have a particular approach or strategy around monitoring your models that you're deploying through this method? Like,
That's
for example, like model drift or just monitoring that it's producing results, the right results?
Right. Yeah, absolutely. So you definitely want to send up monitoring just to ensure that the service is running. And that I think is, again, like something that is a pretty deep topic where you probably want to bring in somebody from like your DevOps team or your IT team more broadly. And then that is something though where I think like more of the paid products like RStudio Connect really shine. So I know, like at our company, we have really talented DevOps folks. We don't have RStudio Connect, but they've set up some pretty advanced kind of custom stuff for us to do this. If you're looking for something that's going to be a little bit easier to use out of the box, I think that's where something like RStudio Connect could be appealing for that monitoring and logging. But it's important to keep in mind in terms of assessing something like accuracy drift, you need the true value of whatever you're predicting. So if it's something continuous like sales, that becomes a little bit easier to get, or some number that's observed. But if you had to have somebody label training data to get your model, to train your model, so if you actually had to have somebody go in and label historical records as fraud, not fraud, for example, that labeling would need to continue for you to continually monitor accuracy. So monitoring accuracy, I think, can be straightforward, but there are some considerations to think through depending on your problem.
Awesome. Yeah, I think these are all really good topics, and definitely I know a lot of data scientists are probably spending a decent amount of time trying to figure out how to ensure that what they just spent a lot of time on is actually going to get used by the business and make a difference. So, I appreciate you taking the time to put this together. I know probably everyone who's attended today has probably learned something valuable. I'm a Python user, so this was really interesting for me to see from the R perspective. And I know there are lots of different tools out there that are trying to do the model building and deployment process from like a UI perspective. So it'll be really interesting to see kind of how these methods start to converge and what the pros and cons are going to be.
Yeah, absolutely.
All right, very good. So we're kind of at the top of the hour here. I want to thank everybody who stuck with us throughout the lunch period if you're on the East Coast of the US and joined us for this conversation. And thanks again, Katie, for putting that together and talking about this super relevant topic. And real quick, before everyone logs off, we do have an upcoming event in 2 weeks. We are launching a new event series. It's going to be virtual. This time we are partnering with Tableau for the entire series. So there's going to be 6 events every other week. And it's all around the concepts of mitigating bias in analytics. So we're going to start at the beginning with data collection. We're going to go all the way through to building algorithms and determining policies and standards around using algorithms in production systems and where bias can be introduced into that process. So I'm super excited about this partnership. It's going to be an awesome event series. So make sure to, keep in touch with us on Twitter, LinkedIn, join our newsletter so you can see some of these upcoming events. Again, everyone, thank you so much for attending, and have a wonderful rest of your Wednesday. See ya.